We continue our lesson 14 on parametric drafting. We have discussed a few of the geometrical constraints, and now we discuss a few more geometrical constraints with the demo. I'll open AutoCAD. Open here. We discussed about coincident, perpendicular, parallel, horizontal, vertical, and we had to discuss the remaining. We discussed equal also, we discussed about fix also. Now we'll discuss about parallel also we have discussed. We'll discuss about concentric, tangent, symmetry, etc. Suppose we have a circle, let us say, and we have another circle, here it is drawn. I want these two circles to be concentric. Then we can apply a parameter called concentric, this one. Click on this and click on this, it has become concentric, it comes inside the circle. Now it has taken the first one as a reference. Suppose we click on the second one instead of first one. Let us see what is going to happen. Concentric is here. This, it has come there. The first one is taken as the reference. And let us see what happens. Suppose we fix one of the circles. Fix this circle in position. Fix. And now let us see what is going to happen if we apply concentric. Concentric. This first, this. It came here, inside the circle. Since we have fixed the circle, bigger circle, it cannot move. Therefore, the smaller circle comes into the center of the bigger circle, even though we click first the smaller circle. Similarly, we click first second circle, even then it comes because this circle is fixed. Okay. Now suppose we remove this fix. Delete this fix, and now we apply fix to the smaller circle. Fix to the smaller circle. Fix applied. Now we will see what is going to happen if we make it concentric. First this, then this. It comes to the smaller circle center. So this is how. And even if you click first the smaller circle or concentric, it comes, the bigger circle comes inside. Suppose we click bigger circle first and then smaller circle, then also it comes because the smaller circle is fixed. This is how the fix command, concentric command works. Okay, it becomes. Suppose we have one more circle, and suppose we want to make this concentric. Click here, concentric. This. It has come inside. Or suppose we have. Well, let us see. We have fixed this one, and we have fixed smaller circle, and we will also fix the other circle here. Now let us try to move. What is going to happen? Let us see. I will try to move the first circle, the bigger one. It did not move. It shows here dimensional value results in be inconsistent with the existing configuration because you have fixed this circle on which cursor is there, and also you have fixed this circle in the position. They cannot move. So there is inconsistency, so it will not move. Suppose we apply for the bigger circle. Let us see what is going to happen. Even it shows inconsistent because the bigger circle is already concentric with the smaller circle here, and the second circle, third circle is also fixed in its position, and bigger circle cannot move because it is already concentric. If you want to move the bigger circle, you have to delete the concentricity of the bigger circle. You will delete it. Now the circle, bigger circle here is not concentric, the smaller circle here, and now you can definitely move the circle, bigger circle to the here it has moved. So this is how the concentric parameter works. Similarly, for anything, it will be normally circle. Even if you take an ellipse, it remains the same. Possibly, let us see one ellipse and second ellipse. Let us see whether we can do this, whether concentric can be applied here. Yes, it is applied. So this ellipse comes inside a smaller ellipse comes inside a bigger ellipse. So same way fixing parameters also works on this. Okay. And similarly, let us see what is going to happen to a square. Because square you can't have a center here. So you can't apply concentric here. Suppose we apply like this. Let us see whether we can do it or not. See, it cannot be concentric. Only circles cannot be concentric. And that locus of the one point is equidistant from all other points. Such figures can be concentric. Okay. Now we erase this. This is about concentric we have learned. And now we'll go to parallel, tangent. We'll go to tangent and collinear and smooth, symmetric. These things we have to learn. Now, suppose we have one line here. I will draw it arbitrarily on the line. And another line somewhere here. I draw. Let us observe what is the collinear meaning. Collinear means both lines in the same line. It should be in the same direction. It is aligned. When the lines are aligned, then it is called collinear. We will see whether we can apply collinear here. Collinear, this one, apply this. See, it is, both the lines are collinear. Now the line is on the same line. Suppose I want to join this line with this line. Then what we have to do is click here and we have a coincident. So we have to apply that coincident. Apply to this end and apply to the other end. So both the ends become coincident. It lies on the same line. Suppose we want to apply coincident to the other point, we have to apply similarly. Coincident. Coincident. I want to be what is concentric. We'll have applied coincident. This, and I want to apply this. It has gone there. Okay. Now suppose we will move this, let us say. We have moved it. And now we apply coincident for these 2 points. How it behaves, let us see. It is joined here. So this is how coincident one. We can remove this. Suppose we rotate this, what is going to happen? Let's see. See, the entire line, both of them rotate together because line has to be always collinear and hence it will not offset from the one line, the one line with the other. It remains the same, so it will rotate together. Suppose we remove this. We delete this offset. So now the line is not collinear. This is only coincident. So now we will see we can rotate or not. So the line we can rotate or not, we can see. This symbol we can use here. Here the line rotated because this point is always fixed. I mean coincident, it rotates along with the line. Suppose I want to rotate from at this center, then what we have to do is you click on rotate this line, consider this point, rotate. We have learned about rotation. And now we'll see, now we have learned coincident, perpendicular, parallel is also tangent. We'll see the tangent. Tangent means a line can be tangent to a circle, to an ellipse, or to any other curve. So we will see that aspect. Suppose we draw a circle, let us see, and we draw a line here. Okay. Now I will draw it a little bit differently so that it looks like it is tangent. No, it is not tangent now. Let me draw a line, something like this. Now this line is definitely in the figure is not tangent to this circle. So suppose we want to make it tangent, what we have to do is click tangent here, here. It has become, see, symbol is this. So these two are tangent. Suppose I want to make this end of line contact with the circle, then we have to click on coincident, this point, and somewhere here you can select. You can draw a line somewhere here. Yeah, radius is drawn. So it has to be tangent to the circle at the same time coincident. What we have to do, whether we see whether it's possible or not. Because it shows center, it is not possible. Okay, it says inconsistent. So we cannot apply this here because they become inconsistent because it is tangent. If you want to make it the contact, then what we can extend the line and here. So now it has extended, now it is tangent. If you want, you can trim this so that the point is meeting. Because the point is, the tangent point is constrained here. This point is constrained. Okay, it is tangent. Now we can apply the consistency whether we see we apply. Here it's not possible because our tangent means it's touching. So it's already touching and hence it is going to be inconsistent if we apply. Suppose we have a circle, we have drawn some line, just point on this, like this. Now this line is already having a coincident with the circle. Now here we will see whether we can apply the tangent rule. Here we can apply the tangent rule because the point which is touching here has moved to another point on this arc, on the circle circumference, and the contact will remain the same. So hence we can apply this rule. Okay, it's touching here. Suppose we want to make this tangent, we can make. There is no inconsistency here. See, I will just show you once again. Tangent. I want to make this tangent to this because the circle has moved. Suppose, let us say, I will fix the circle. Fix the circle. It is fixed in position. Now, whether I can move this line or not. Even then, move this line. Yes, the circle diameter has reduced and the contact remains the same. Only thing is, because the circle cannot move in front position, but diameter is free to be reduced. So diameter is reduced such that this becomes, the diameter becomes, see, suppose I draw it here. So it is this diameter, it has become, the diameter is equal to the perpendicular distance line, I will now. PR means perpendicular. So this becomes the, this length of the line becomes the diameter, becomes the circle radius that the circle has changed. Now I will just show you once again how it changes. I am applying a tangent rule here. See, circle has changed, line is also extended. Now let us see what is going to happen if I fix the line also. Suppose I fix the line. Let us say line is also fixed at this point. Let us see. Now whether we can draw the tangent or not. Let us see. Tangent. Yes, we can draw because the line is fixed, but point is fixed, but it can move as well to the circle. Okay. This is because its length will be changed. The point, this point is fixed, but its length is changed. Line length is changed. See here once again. I will make it tangent. Line is fixed. This position is fixed. I will make it once again. See, this point is fixed in the same position. Contact is also maintained. This will move from there, and circle diameter also will get changed a little bit. Or the diameter circle remains the same because this can always, this line can swing at this point. This point is fixed. From that point it will swing. At the same time it can extend and diameter circle remains the same. So we will learn about more as we go to dimensional constraint. Now we have learnt about tangent, horizontal, vertical, collinear also we have learned, symmetric, equal. These two things we have to learn about. Let us say symmetric. Suppose there is a line here. There is another line. See, like this. So we want it to be symmetrical. No constraint have been applied here. And that is something like a mirror. You can say it is symmetrical means from symmetry means there should be one parting wall. There should be one wall. Let us say there is a wall. This is a wall line, let us say. How to make it symmetrical? Let us learn about it. Now I want symmetrical. So what we can do is symmetry, click. First object, this is an object, and click this. And then second object, click this. And then it shows symmetrical line. This. See, now these two becomes symmetrical. Okay. Parting line, it has become symmetrical. I will erase this. This same inclination. See, it is inclined certain angle here, and it is inclined at the same inclination like a mirror. See this angle, let us measure it. how much? 11 degrees. This is also 11 degrees. But in the opposite direction. It is like a mirror. 11 degrees. This is a mirror. Mirror-like thing. And length is not the same. Suppose you want to make the length equal, what you have to do is apply equal. This. Lengths are equal. Okay? It's symmetrical and lengths are equal. But you can also bring very true to this point by moving this. Then we have to give another constraint. So let us not worry about it. We can do so many things. But now the line is symmetrical. It is not the mirror image, but it is symmetrical. Mirror image means this point, when you draw a perpendicular, it should meet here. So that is the mirror image, but it is not the mirror image, but it is symmetrical, symmetrically placed. Okay. Now, I will erase this and we'll learn something more about symmetrical. Suppose I draw a line here, vertical line. Here we can understand how it can be more symmetrical. Another line here. And I want these two lines to be symmetrical. I have to draw some particles. I will draw this line very close to this. So how it will be symmetrical, symmetry is set, let us see. See, that means here, since the lines are both vertical, distance from this line to this part, symmetrical line, and distance from each plane to the other line are the same, are equal. Okay, here there are, what are the constraints applied here? Line automatically it is applied vertical constraint. Here I told you auto constraint I have checked, so it is applied automatically vertical constraint. Auto check, I will just show you auto check. Here all are checked, so it automatically applied. And also this is also automatically applied, and this is symmetrical. Symmetrical, it is becoming symmetrical. Now I think we have discussed all these things, collinear, symmetrical, etc. All these points we have discussed. Tangent also we discussed, parallel also we have discussed. Smooth, one more. Smooth is applied to the curve. Suppose you want so many lines joined together, you want to make it smooth. Let us say. You want to smooth. Let us see whether we can apply smooth here. Smooth. We can't apply smooth here because the line, this constraint is there. So to apply smooth, what we can do, perhaps we can delete this constraint and delete this constraint. Delete this constraint. Now let us see whether we can apply smooth. No. This can basically apply for the curves. Smooth can be applied to the curves. We'll discuss about it later on about smooth after discussing the dimension line. Let us see we can apply for the curve. Now let us select spline. First let us create a curve. This is one curve and another curve. Another curve we will create from here. Now we have to remove this because it will constraint will overlap and it will have a conflict. So we have to remove the constraints. Now we can try to apply smooth. So the curve, these two curves join, but they are not smooth. At the end, it is small, sharp, and it asks like this. So select first spline curve, select this, and second spline curve, select this. It has become smooth. Similarly, we can apply here whether it's already applied, it becomes one single curve. So you cannot have once again smooth. Let us see if we can. So it says first it has become smooth. So both places we selected and we smooth. This is how smooth command can be applied. Now we'll do a small exercise on this, applying all the constraints. Let us uncheck all these things. Now we don't think. We'll do an exercise first. Like this, like this, like this, like this, like this. We draw some irregular figure. Now, we'll first remove all the constraints, delete all the constraints, start from the beginning how we can apply for the entire picture drawing, not picture. So there is no constraint on this. We start applying. We want to make this object a apply the, suppose we remove this, let us say a symmetrical object we make. Let us see how we can do it. So I will join these two, but constraint is applied. I am going to remove this constraint. So no constraint is applied on this job, and we'll remove this line also. This line also will erase and join this with this. Or we'll make it inclined. We'll make it inclined. I will take a odd figure to show you how constraint applied and make an even figure. Like this. Suppose I want to make this, I will remove this constraint. Delete. Now let us see how we can make a regular figure this constraint. I want this line to be horizontal. Okay, I click on this. It has become horizontal. I click on this. This is horizontal, and then I make this also horizontal. It has become horizontal. Then we have to trim these lengths or make it equal. And then I want to make this vertical. This I will make vertical. It has become vertical. And similarly, I will make this vertical. This also become vertical. And I want this line to be coincident. This and this, it has come there. Or if you click the other one, we'll see. First we'll click on this and bring this. First we click on this, coincident, so joined. Okay, and similarly we'll make coincident this and this, it has joined. So Now, we want to make this and this equal. So we can apply equal. Only thing it should not be conflict. So it has become equal. And now we have to make this also equal. This is equal. And now we make this and this coincident. This line has come up here. And now it has come. Now we have to bring this line here. So what we can do is we try to make it coincident. Just come here. And we will remove this. Otherwise the line may not move. We will do one thing. We will bring it coincident. It's come. Okay. Now this we will make coincident. Just come here. And we make the other one also coincident. Let us see whether we can do it or not. Oh. So we have to make this vertical. Suppose I keep this vertical. We are not applied vertical here. Apply vertical. And now we will see whether we can make it. This also we have to make vertical. So now lines we have aligned. Now the bottom one will make it horizontal. Let us see. Yes, it has become horizontal. And now these two lines are not equal. This is vertical, this is vertical. These two lines are not equal. So shall we make equal? Yes, it has become equal now. So the lines are equal. This is equal to this, this is equal to this, this is equal to this, this is equal. This is single line. These two lines are equal, and these two are equal, and these two are equal. Now we want to make it symmetrical about a line. So let us see whether we can. Or if in a midpoint it will be symmetrical. That is all. Or if you select some other point, let us see. If we want to make this symmetrical, then we can select this, all the thing, the entire figure. Let us see whether it is possible or not. It may be or may not be possible. Let us select and see. Symmetrical, whether we can, because it is two different figures. See, symmetrical, select first object. See, this cannot be applied in conflict. You can't apply it. So what we have to do is to make it, because this line is equal, no, these two lines are equal, these two, you can't apply this symmetry here. Suppose we'll see what other things we can do. Symmetry, or else we can apply this and this. And suppose I apply. No, it is symmetrical. This is closer, so it is symmetrical. Lines are horizontal, it is symmetrical. This line, you can't apply the symmetry there. First object, second object. See, now it has lines Because lengths are not constrained, it has become symmetrical. This is how we can do symmetry. So you want to hide all these things, you can see all constraint can be hidden. You can hide the constraint. Hide, 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 hide all constraint, you can see all are hidden. So symmetrical line, if you want, you can remove the symmetrical line. Show how the object which was in a regular way, made it a regular simple object. This is how we can apply various constraints. Till now I have discussed only geometrical constraint, and then in the next class I will discuss about the dimensional constraint. So we end the class now.